Hi guys, this is Get That 5 with Anne and Rachel. Hey Rachel, what are we doing today?
So today we will be reviewing Unit 1 of AP Statistics, exploring one variable data.
To start us off with, what is statistics?
Statistics is the study of data. The data contains information about a group of individuals, and the information is organized using variables.
So, what are variables in statistics? Because I know that variables in math are x and y. Are variables in statistics exactly the same?
They are similar, because statistics is also a kind of math. Variables can be kind of that way, but they are not used in equations. Moreover, variables are used to place data into categories. So we have categorical variables and quantitative variables. Categorical variables places individuals into specific groups, so like gender, eye color, hair color, size, grade, that type of thing. Quantitative variables take on numerical values for which it makes sense to do arithmetic operations like adding and averaging. These fall into two different categories, discrete and continuous. Discrete variables are numerical values where counting makes sense. In other words, decimals would not be an appropriate way to record the data. Zip codes and area codes are an example of this. Continuous variables are numerical values where decimals are appropriate. It usually involves some form of measuring, so like length or time.
With these variables, we can collect our data. However, in statistics, data isn't just being collected, it is also being visualized and then analyzed. So, there are multiple ways of visualizing data. What are they?
You can visualize data in statistics using tables and graphs. Commonly, you can use one-way tables, two-way tables, bar graphs, histograms, box plots, stem and leaf plots, dot plots, and even cumulative relative frequency graphs. All of these have their unique attributes and specialize in different types of data.
When visualizing data like this, we usually call them distributions. Given distributions, we will have to be able to describe them as well.
In statistics, there's this acronym called SOCS plus context that is used to help remember how to describe distributions. The S stands for shape, O stands for outlier, C stands for center, and S stands for spread. So when describing a shape, there are many different ways to describe this. You can describe it as unimodal with one peak, bimodal with two peaks, uniform with approximately the same values all around, symmetric, where it's the same on one side and the same on the other, left skewed, where there is outliers on the left side and most of the data is on the right side, or right skewed, where there are outliers on the right side and most of the data on the left side. An outlier can be described as high or low, and most of the time it will be seen visually and you will have to call it a possible outlier. However, if you do have the data points, you can calculate the outlier boundaries. So there are two ways to calculate the outlier boundaries. One way would be the IQR rule, and the other would be using standard deviation. With the IQR outlier test, you find the quartile 1 data point and subtract 1.5 times the IQR from that, and that would create your lower boundary point. So anything below that would be considered an outlier, and then you would take the quarter 3 data point and then add that to 1.5 times the IQR, and that would be your upper boundary. So anything outside of those boundaries would be considered an outlier. This is similar with the standard deviation outlier test. So the mean plus 2 standard deviations is the upper boundary, and then the mean minus 2 standard deviations would be the lower boundary. The center can be described either using mean or median. Mean is the average of all the data, and it is used when the distribution is approximately symmetric. The median is the center point value, and that would be used when the data is slightly skewed left or right. There are three different ways of describing a spread. You can use range, which is the maximum value minus the minimum value. However, range is less preferred because it tells you less about a distribution. So it is advised to not use range if there are other options available. You could use standard deviation when the data is approximately symmetric. Standard deviation is the average deviation of an observation from the mean to the data set. So it goes hand in hand with mean and the data needing to be symmetric. You can also use IQR, which is quartile 3 minus quartile 1, and that is used when the data is skewed left or right.
With SOCs, you have to make sure to include context when describing a distribution. Otherwise, without context, the person reading your answer wouldn't know what you were talking about.
Along with what we've been talking about with data points and describing, there is this thing called percentiles. Percentiles measure the percent of observations that fall below a value. So as I've been saying, there are quartile 1, quartile 3 points, and there's also the minimum and the maximum. So like the 0th percentile would be the minimum value, the 25th percentile would be the first quartile, and the 50th percentile would be the median. The 75th percentile would be the third quartile, and the 100th percentile would be the maximum value. These points, or these data points, create a 5-number summary. A 5-number summary consists of the minimum, quartile 1, median, quartile 3, and maximum. It is very important to know how to find these numbers in statistics, and these will often be used to describe a distribution along with SOCs.
So, when talking about distributions, there's a certain type of distribution that is important in statistics. This is the normal distribution.
A normal distribution has a few key qualities. It will be symmetric around the mean, and the mean, the median, and the mode will all be approximately equal. 50% of the observations are less than the mean, and 50% of the observations are greater than the mean. In a normal distribution, approximately all of the data lies within 3 standard deviations above and below the mean. When dealing with a normal distribution, there is this thing called the empirical rule. We can determine the variability of the data in terms of percentages. 68% of the data is likely to be within 1 standard deviation around the mean. 95% of data is likely to be within 2 standard deviations around the mean, and 99.7% of the data is likely to be within 3 standard deviations around the mean. These 3 percentages, 68, 95, and 99.7, describe the empirical rule and can be used to find any data point on a normal distribution when you already know the mean. Similar to the empirical rule, there is this term called the z-score. The z-score determines how many standard deviations away from the mean an observation is. To find the z-score, you can subtract the mean from the data point and then divide it by the standard deviation. This will tell you how many standard deviations above or below the mean a data point is. Positive z-scores mean larger than the mean, while negative z-scores mean below the mean.
That's it for Unit 1 of AP Statistics. Thanks for listening to Get That 5. We'll see you next time with the next unit.